Welcome aboard, we enthusiasts. We have entered the world of electromagnetism. And in the previous session, we have started electrostatics and we have seen how closely it's related to gravitation. And today, we are going to talk about electric fields. Fields are something which are closely related to forces and are always associated with electricity, magnetism and gravitation. And since we are also talking about electric fields, it's a good time we should also talk about gravitational fields which are there around planets and fields which cause all kinds of planetary motion. So that's what we're going to discuss. With me, Shreyas, your master teacher for physics at Vedantu, and I'm going live from Bangalore. So welcome aboard everyone, all the new members and the old members to the We Enthusiast family. So we all call ourselves over here We Enthusiasts because we are all eagerly waiting for our exam, and along with that eagerness guys, we also are going to do all that hard work which is necessary to crack that examination. So that's why we have started this flash series, and in this flash series we are not only doing the 11th standard portion. I'm doing the 11th standard portion on Mondays, Tuesdays and Wednesdays usually, and on Thursdays, Fridays and Saturdays I'm parallelly doing the 12th standard portion. And I'm going to make sure that most of the syllabus is complete by January, and definitely by April we will be mastering these topics again and again, including some problem solving sessions, advanced problem solving sessions, etc. So do not worry, you are at the right place. If you are a dropper, if you are a 12th standard student, and even if you are a 11th standard student. So today we are doing a 12th standard topic, and we are going to do the flux, the electric field, the gravitational field and all those kind of things. So if you do not want to miss these flash series, then you must subscribe. You will see a red colored box on the bottom out there. Do not forget to hit that subscribe button, else you'll be missing it out. And even after subscribing, you also need to hit the like button, because then YouTube won't recommend you our videos in case you do not like and subscribe. So do not forget to hit that like button out there. So welcome aboard Ankit, Ruhi, Jayan, Juhi, Achyut, Krito. Welcome Science Priya, welcome everyone, welcome Ankit, welcome Ravi. Hello Hoin. I can see a lot of new members, and I'm seeing so many new familiar faces who are recently they have entered our family, and I can see that they have started becoming regular in these sessions. I'm so glad that this channel is making such a huge impact. And I have a special announcement for you guys. I'm going to make a special, yes, the starting pick, yes, it was kind of Einstein's theory, you can say. Okay. Yes, Huin, I saw you yesterday and I can see you today also. I'm so glad you are here, and wish you guys a very happy Dhanteras. You know, Diwali has all these days, and so Diwali has started, guys. Wish you all a prosperous, happy Diwali. Tomorrow, I won't be coming live on YouTube, but like I said, I will be doing a special thing for all of you. I'll be coming live on Instagram for you. So I hope 9 p.m. works for everyone tomorrow night, Saturday night, tomorrow at 9 p.m. How about it, guys? What say? How about going live on Instagram? I'll be coming live on Instagram. I want to meet you guys on Instagram too, apart from YouTube. Alright, so my Instagram handle, in case you have missed it, it is Shreyas_Vedantu. That's where you can catch me live tomorrow at 9 p.m. sharp. I will come live. Alright, yes, around 9 p.m. I think all the pujas and everything will be done. So around 9 p.m. is what I'm planning. And in case any delay or anything like that happens, I'll let you know on Instagram itself, and even on Telegram I'll post the update. All right, so I'll be seeing you live. You can ask me all the questions, but do not ask me doubts. Okay guys, doubts is something which we can take it some other time, but if you want to know about me, if you want to just talk to me in general, I am ready to talk tomorrow. Tomorrow is also Children's Day, so I think it's a very good occasion to come online with all of you. All right, so let's do that, guys, tomorrow. Yes, let's begin our session then. And today we are going to talk about the concept of electric field first. So what is this electric field? See guys, understand, if I have two charges, let's say Q1 and Q2. These charges experience some kind of force between them. Correct? They experience something called as an electric force between them. It could be repulsive or attractive depending on the signs of the charges. Now, imagine the second charge is not there. Imagine the second charge is not there. It's somewhere really far. Only Q1 charge is there. Obviously, it won't experience any force. So if you just have one single Q1 charge, it won't experience any force, nor will it apply force on anything around it. Because there is nothing around it. It's bichara lonely in this universe. Now, imagine suddenly from nowhere I put this charge Q2 over here. Suddenly I put this charge Q2. I know this Q2 charge will start experiencing electric force. Correct? The moment I put Q2 charge, it suddenly experiences electric force. How the hell does it know that I have to be attracted or repelled by this guy and by how much magnitude as well? How did this know that I have to be repelled, attracted by this so and so magnitude of force? That means even before this charge was present, there was some kind of an information which was present even before putting that charge over here. And that information was not only here, in fact it was there everywhere around this charge 1. This is just information. It is telling, oh, you are this close to this charge. If you are close by, okay, you are this close to this charge, so the information will be different. This information enables when you introduce this charge Q2 over here, to notify or to get that knowledge that, oh, I am this far and this charge is of so and so value, so I will experience this much force, and that's how this force gets applied. So that piece of information, guys, is called as field. So field is nothing but a piece of information which is there around every charge or any charges around you. And for that information to exist, you do not need other charges. Just one charge can have its own information around it. Another charge will have its own information or its own presence around it. And if you have multiple charges, obviously each charge will introduce its own pieces of information, which is called as field. They will all have their own respective fields. So at that particular point, you will have the total sum of all their fields. And field is a vector quantity. So when you calculate the total field or the total net information out there, you have to add them vectorially. I hope this is clear. Yes, it will also be around the masses. So around a mass, what you will have? You will have gravitational field. So it's the same concept. If you have two masses, how does this mass know I have to be attracted over here? So there is a information of mass around it, and that is called as a gravitational field. Alright, so that's what it is. Now let's see what's the formula, or how do we define electric field or gravitational field. Both definitions are very identical. Now you can see I have shaded it very differently. Reason is, when you are close to the charge, the field is very strong, and as you go far away, the field becomes very weak until you reach a point where the field becomes so negligible that I assume that the charge does not have any more influence. But strictly speaking, the influence of the charge never becomes exactly zero, even if you are 100, 200 kilometers or even light years away. So no matter how far you go, the charge always experiences or exerts some field. Understand that? But we generally neglect the values when you are at a very safe distance of few centimeters or meters or whatever. Now, if you have a charge, okay, and let's say I am at some distance over here and I want to know what is the field at this point. So I'm at some distance r from this charge. I want to know what is the field. Now I'll tell you the way field has been defined is, now this is the definition. This should go in your books. I hope you have your pens and papers ready. So the definition of field is given as the force divided by Q naught, where Q naught is nothing but the test charge, and the test charge has to be always positive, such that that charge itself should be very, very small. That charge itself should be very, very small. What does it mean? Field is force acting on a charge, alright, where that charge is very, very small. Why should that charge be very small? Because if you have a big charge, then that charge itself will create its own field. So understand, you need a minute charge so that you can test the field. Remember, you cannot say I will have zero charge, because if you have zero charge, how will you test the field? So I hope you understand the dilemma or the problem that I am facing right now is that to test if there is some field, I need some charge, but I don't need a big charge, because the moment the charge becomes big, then that charge itself will create its own field. So we'll have a test charge which is very minute, very infinitely small, and that is what is going to give me the field. I hope this is clear. This is the definition of field, guys, and actually speaking, this is a vector equation. So field is always in the direction of force, but force on which particle? Always the positive particle. So imagine if I am over here, this is a positive charge, right? So if I put a positive test charge over here, what direction will the force be? Obviously it will be this side. So the electric field will be on this side. Understand? If this charge was negative, then again if I put a positive charge here, the field will be this side. So the field's direction is same as the direction of the force on a positive charge. Why positive? That's our convention. So this is positive only because of a standard, or we can just say it is a convention. That's it. I hope everything is fine till this point. Very good. And what is the unit of field? The unit of field you can clearly see from here. It is nothing but Newton per coulomb. Newton is on the top, coulomb is on the bottom. So the number of newtons which acts per unit coulomb is nothing but field. And later on you will also see this is also an equivalent unit, volts per meter. Both are equivalent. You will see that later on, that volts per meter and Newton per coulomb both are equivalent units. Is that fine, guys? All right. Well, let's not talk about light today. Yes, light does not have mass, it has momentum. We'll talk about it in some other topic called as photoelectric effect. Guys, please concentrate. You should concentrate on the current topic. Do not let the discussion on the chat go somewhere else. And if somebody is trying to do that, you guys should act like the defenders. You should act like that antivirus. You should be like, hey, come on, get on track. Do not worry about it. Our focus is JEE. Our focus is this current topic, this current chapter. So focus on the current topic, guys. All right. Now, Achyut, electrostatic shielding, we'll talk about it in Gauss law, not now. Now, if this is clear, then the field due to a point charge, let me tell you the formula. So, field due to point charge is given by E is equal to, think about it, from the force, just remove one charge term and you will get the field value. It will be K Q divided by R square. So guys, if you remember all the formulas which I have given you in the previous session, or if you know the formulas for forces, believe me, you also know the formula for field. Just remove one Q, that's it, that is the answer. So this is the formula for field due to a point charge. Okay, shall we see the field now due to different geometries? Because now if you have different geometries like a ring, like a sheet, like a disc, like a sphere or stuff like that, we can find out the field due to all these geometries. All right, so let's do that. And before doing that, let's also see what is the meaning of electric field line. Now, electric field lines are those lines, okay, electric field lines are those lines which point in the direction of the force exerted by the charge on the test charge. So for example, if I take a positive charge, I know if I put a positive charge over here, alright, if I put a positive test charge here, the force on it will be outwards. If I put a positive charge here, the force will be here. If I put a positive charge here, the force will be here. So if I keep moving in that direction, so understand, if I put a positive charge here, I know the force will be in this direction, so I move in that direction and I stop there, and again see what is the direction of the force. I see it is this direction, so again I continue, stop there, and I see again where is the force acting. I see it is again in that direction, I keep moving. When I join all those points, that is the field line basically. So field lines points in the direction of the force on a test charge which you place around it. I hope this is clear. Very good, very good, very good. So now if you take a positive charge, can I say the field lines are radially outwards? And if I have a negative charge, then the field lines are radially inwards. So that's the big difference. Remember, field lines always end, electric field lines always end on a negative charge. Electric field lines always start from a positive charge. Another important property, I hope you're writing this down in the short notes that you're making. I would request the moderator to please block Nitish if he is causing any nuisance. Alright? Please do that. Alright. Now, here is the thing, guys. Understand, if this charge is different, if it is more, then the number of field lines coming out of it will also be more. If this charge is small, field lines will also be small. That's the next property which you should know. So the field lines depends on the charge or magnitude which is present on it. Alright, more the number of field lines, more the amount of charge. Another thing, these field lines, okay, will only terminate at infinity. When it starts over here, it will now only terminate at infinity, and here it is starting from infinity. So there are only typically 4 options for a field line. It can start from positive or from infinity, and it can end at negative or it can end at infinity. These are the only available options with electric field lines, and same with gravitational field lines, of course. Now, these are positive and negative charges separately, but what if I bring them closer? These field lines will bend and they will look something like this. So this is how the electric field lines look like. You can see they are clearly originating from positive and they are ending on the negative charge. In fact, such a system is also called as an electric dipole when you have same positive and same amount of negative charge. And some of the important properties that you can see from here as well is that, understand guys, electric field lines do not intersect each other. Okay, so they do not intersect each other, and if they did, then that means there are 2 directions of the field, which is not correct because that will create an ambiguity. You can only have a line like this. You cannot have a line which is intersecting like this. That is not allowed, because wherever it intersects, then there will be 2 directions of field, which is not possible. It has to be unique. Next thing is the tangent to field is the direction of the field itself. The tangent, if I draw a tangent here, then that is the direction of the electric field at that particular point. That's what it means. And one last important property is the density of field lines. Alright, the density of the field lines is directly dependent on the field itself. In fact, the field strength, I will say. That means if I come over here, I can see the spacing between them is very, very less, the field lines. So I will say the field is very strong. If I go far, I can see the spacing is really less. So here it is weak. So the spacing, how closely they are packed, the density of field lines directly tells you about the field strength of it. So very, very important properties. I have given it to you. I hope you have made notes, and then we'll go to the next thing. Similar to magnets, yes, this is like North Pole and South Pole. Similar, not the same. You will see why in magnetism. Yes, okay. Now, so guys, all these pointers are important. Remember, stay till the end because I am going to start with field and I am going to go till flux. Gauss law will be completed in a separate chapter, and all those of you who are expecting I will complete electric field, potential energy, Gauss law, ye wo sab in one lecture, guys, you are at the wrong place. I will not do that. I will be doing each of these big topics in separate sessions. I am going to spend 1 week because remember guys, there is enough time. I have made one entire timetable, almost a tentative plan for myself till the month of January, so that I can complete all your syllabus. Yes, all your syllabus, and I have made that plan. So guys, understand, I have all in mind. So do not worry, we are going to cover all the topics. So do not go behind, oh, I have to complete everything in one lecture only. If you go like that, then that's it. You're doomed. You will not understand anything. Okay, fine, Nitish. No problem, but behave. Okay, no problem, but behave. Great. No, Dinesh, the charges can move. Okay, chalo. The charges can move, but it depends. So I have given you the properties. Now gravitational field also behaves exactly the same way. Achut, I like all the topics, but yes, electromagnetism, gravitation, rotation, all these are my favorite topics. Okay, so for what do you say? For gravitation, the field lines, believe me, are always inwards. Keep this in mind, very important property. For gravitation, field lines always end on the masses. They will never originate from the mass. Write it down, guys. Why can't they originate? Because if you put a test mass, what will happen if you put a test mass, guys? On the test mass, what will be the force? It will be towards the other mass. So field lines will always terminate. So very, very important property again. So field lines only terminate on the mass. They can never originate. And the other properties are still the same. Like two field lines can't intersect. Wherever the field lines are close, it is strong. Wherever they are far, they are weak. All those other properties are same. So I'm not repeating that. So let me just define gravitational field. Gravitational field will be force, but instead of charge, it will be force by mass. This is my test mass. So this will be limit m naught tends to 0. So this is the way gravitational field has been defined. And what will be the unit? It will be obviously newtons per kg. So that's how it is. So it is newtons per kg. So that's the big change, guys. I hope you understand. Instead of newtons per coulomb, what is the difference? It is newton per kg. Okay, again it's a vector equation, so that's something which you should remember. Similar formulas. Negative mass, Suhas, we don't talk about. In JEE we do not have negative masses, we just have positive masses. If you take engineering physics or MSc physics in JEE, once you crack the exam, obviously you can talk about all this. Alright, great. So that's one thing. Now let's revisit all the formulas, the geometries. I hope you recollect or remember all the formulas which I have discussed yesterday. And in case you are new to this session, no problem, I am going to show you all these formulas for field. Okay, so electric field due to a uniformly charged sphere. So electric field, guys, due to a charged sphere, think about it. This sphere has to be non-conducting. This has to be non-conducting, because if it is a conductor, then all the charges will run away onto the surface. Remember, that's the property of a conductor, all the charges run away to the surface. So it has to be non-conducting, so the charges are intact even inside that sphere. So what will be the field? So remember, E will be, the force formula was KQQ by R square when you are outside, right? R was the radius and small r is the distance. So small r was the distance, capital R was the radius of the sphere. But in case of field, this small q will not come. That's all. That's the big change, and nothing else will happen. So this is the total charge q on the sphere. And if you are inside, then what will be the formula? It will be kq small r divided by capital RQ. So this is when you are inside. I hope you can see the similarities in the force and the field. So if you know the force formulas, you also know the field formulas. That's it. Okay, I hope this is clear. I hope this is clear, everyone. Is this fine? So similarly, can I not talk about gravitational field due to a solid sphere? Think about it. What will be the gravitational field again due to a solid sphere? So assume the mass to be m. Assume that we are at some distance r. So the field formula, guys, gravitational field will be G m by small r square. That is if r is more than r, and it will be Gm small r by capital R square if r is less than r. So that's the same formula. Instead of one extra m, that small m has gone, because when you find field, remember you always divide by one mass or a charge. So that mass or charge goes away. Alright, very good. So this is another important formula due to a solid sphere. Keep this in mind, keep writing, keep practicing. It should go into your head. That's why I'm giving you some time. Keep writing all these things. Very, very important. Keep a pen, paper in handy. only then it will enter your head. This is not a movie, I hope you know that. Alright, next, due to a hollow sphere, so all the charges are on the periphery only. So these charges on the surface, that's it. So in that situation, again, if assume the total charge to be Q and assume that I am at some distance r from it, so the formula will look something like this. If I am outside, it is kq by r square. So that is when I am outside, and when I am inside, remember it is 0. So no matter where you are, even if you are at the center, here, there, everywhere the field inside is 0. Everywhere. It cancels out from all the charges. That's how it works. It is 0. I will talk about potentials and potential energy in a separate class. I have kept a separate session only for potential energy and potentials. So I don't want to confuse you with all the formulas in one day. So just observe for field and forces today. Alright? Yes, Saeed, it's been raining in Bangalore. It was raining very heavily. Okay. Next, for hollow shell, same formula again. E will be equal to Gm by r square when r is more than r, and it will be 0 when r is less than r. That's it. So that's the formula for gravitational field due to a hollow sphere or a shell. Just a shell, there is nothing inside. It's hollow sphere. Think of it. It's a thin shell, small thickness. That's what it is. Okay. So Arihant, I cannot promise you that I will take as much as time required to complete a topic, guys. Okay. So I'm not going to hurry up things. I'm just going to tell you all the things which I feel are important. Because if I cut down on the class timing, then what will happen? You will be missing out on all the things. I hope you understand that. Okay. Yes, surely Suhas, why not? We can definitely have a session like that. Surely we will conduct a session. I'll plan for it, okay? Just, I have a lot of things running. Guys, even apart from YouTube, I also conduct my regular classes. I conduct micro courses and so many other things, planning, everything. So understand, I also need to make time for things. I'll definitely make time for all the special things that you are requested for. Don't worry. Okay. So now, for a ring, guys, for a ring, what will the formula be? Look at it. For the ring, what will the formula be? It will be KQ, and if this distance is x, it will be KQ x divided by KQ x by r square plus x square whole raised to 3 by 2. So that's the formula for a ring. Straightforward. We have discussed this yesterday, that extra q will not be there. So this is the field due to a charged ring at this point. In fact, this charge is not even needed. Okay, so just forget it. Alright. So then similarly for a ring, this mass is again not needed. Understand that? So this mass is not needed. So the gravitational field will be Gm x divided by r square plus x square whole raised to 3 by 2. So that's the answer for this. So that's the field due to a ring. Now I'm going to give you some special geometries. Not many people remember or know these formulas. So pay attention very carefully, guys. Okay. So this is a very long wire which is uniformly charged, and the linear charge density is given, lambda. Now lambda has the units of coulomb per meter. It is called as linear charge density. So how much charge is there per meter? That is called lambda. If I take 1 meter of wire, how much coulombs is there? That's the meaning of it. And let's say it's not even a long wire, it's a finite wire. Okay? It's a line charge, it's a finite wire. So you want to calculate what is the field at this point. Now the field at this point, believe me, will have two components. One component will be like this, Ex, and the other component will be like this, Ex and Ey. There will be two components of the field at that particular point. And I want to know what these both components are. So I need some additional data. So this angle over here is alpha, and this angle over here, let's say I call it beta, and this distance I call it d. From this point to this point, that distance is d. Okay, so do you know what these formulas are? Okay, first let's talk about Ex. Any guesses what these formulas are? Charge density is per volume, just density is per unit volume. So this is linear, means per length, and areal density sigma is per unit area. So that's the big difference. I hope, Saeed, that's clear. Jay, this is not for class 11th, but if you're preparing for Olympiads, then it is for you. Or if you're preparing for KVPY and all that, again, only then it is for you. Else, for 11th standard, we have Monday, Tuesday and Wednesday classes. So only for Olympiads. Alright. Now, what is Ex? Come on guys, what is Ex? Do you remember the formula? It is 1 upon 4 pi epsilon naught. Lambda is there, and you have that distance d, okay, and here you get some terms. What are those terms? Any idea or any guesses? Think about it. Any idea? No? Okay, I'll tell you what it is. It is sine alpha plus sine beta. These are the terms, sine alpha plus sine beta. Do you guys now remember this formula? Alright, so this d is that d over here. If you don't like that d, you can also put r. It's okay. You can also use the symbol r, provided you change it over here as well. So then make it r over here. That's the same thing. Okay, so this is a formula for the electric field in the x direction due to a wire in the x direction. At this point, each charge will give rise to field like this, different directions. So the net field will be somewhere here or here, I don't know. So the net field will have two components, one in x and one in y. Understand that? Okay, now I'll tell you an easy way to remember it. Okay, now I'll tell you the easy way. Imagine the wire was infinitely long. So if you are here, then what will be alpha and what will be beta? What do you think alpha and beta, those angles which are subtended, be? I think they will be 90 degrees and 90 degrees. Don't you see that? No, it is not different. You will see that. Okay? Just see that. I think the constant, I have screwed it up. Once again, I'll just come to that. Hold on. Is it fine till here? Okay. Is it fine till here? Now, understand, if you put sine 90 over here and sine 90 over here, what will be sine 90 plus sine 90, guys? What will be sine 90 plus sine 90? Think about it. Just once again, I'm just thinking, did I miss something? No, everything was fine. Everything was fine, guys. This was correct only. I don't think there was any mistake over here. Yes, this was 1 upon 4 pi epsilon naught only. Alright, so this was fine. Yes, this was, yeah, just one second, I was just checking if I did any mistake out there, but yes, this was correct. There was no problem out here. Alright, so guys, if both the angles are 90 degrees, then understand this will become sine 90 plus sine 90, 1 plus 1, 2. So that 2 will cancel out here, it will become 1 upon 2 pi epsilon naught lambda by r. Isn't it the standard formula for an infinitely long wire? I hope this is fine. So guys, understand this is a special case when it subtends different angles alpha and beta. I hope this is clear. Okay, now The way to remember EY, electric field in the Y direction, guys. Same thing, just put everything same. Lambda by R, but instead of sine alpha plus sine beta, it will be minus. Why will it be minus? Think about it. If by chance both the angles are same, alpha and beta both are same, don't you see the fields from these sides and these sides will be in all the possible directions, and there will be no net y component? I hope you see that there will be no net y component. So when the angles are same, the answer for EY should be 0. So that's why there is a minus sign, but it's a cos term. So cos alpha minus cos beta. So that's the difference. I hope this is clear. Okay, no problem, Nijarsan. I was just confirming once, seeing that if I have made any problem, but it was fine only. Nothing was problematic. Okay, so remember both these formulas. This will help you calculate the field in both the directions due to a linear charge density. Syed, why doesn't Pandu come? I don't know, but maybe I'll bring him sometime later. But these topics are really huge. I do not have so much time. That's why. All right. Now, if this formula is clear, now let's go to the next formula. Due to a charge sheet. Do you know what is the formula due to a charge sheet? A lot of people get confused. So first of all, imagine this is a sheet and the field lines due to them will come something like this, and it will also go at the back, something like that. Okay, so it will also go at the back. So this field, understand, first of all, it is uniform field. What kind of field is it? It is a uniform field, and this sheet is charged, and it is charged with a value of sigma, which is expressed in coulombs per meter square. This is called as areal charge density, because it is per unit area. How much? If I take 1 meter square of area, how much charge is there? That is sigma. I hope you understand that. Lambda is for linear, sigma is for areal, rho is for volume charge or just the density. So that's how it is. No problem, Ryan, you can always watch the replay. Yes. Now, gravitational field for line charges, the formula is the same, but you will not get questions on that because you will not have a planet which is in the shape of a line. So generally those kind of problems are not there. Same thing, you will not have a planet which is in the form of a sheet. So that's why those kind of problems are not there. Alright, but you can still always get it by comparing both the formulas. So if you compare both of them, you will always get it. Okay, so what is the value of the field? The value of the field is sigma by 2 epsilon naught. So that's the formula which you should remember, sigma by 2 epsilon naught, and I hope you also know 1 upon 4 pi epsilon naught is that constant which we use as 9 into 10 to the power 9 SI units. So you can get the value of epsilon naught from here as well. Alright, is this fine, guys? So remember how to recollect this formula in the exam. If you imagine a sheet, the field will be traveling both ways, so it will be divided by 2. So that's why the 2 factor is there. Understand? So whenever the field gets divided on both sides, that half factor will come. If field is only coming from one side, then understand that 2 factor will not be there. That's how you can remember it in the examination. Okay, so that's an easy way. Let's go to the next. What is the relationship between force and field? What is the relationship between force and field? Gopal, I just said if you have a sheet, then the field will go this side and this side. So think of, while you remember this formula, divided by 2 because 2 sides. But if field lines are coming only on one side, which will happen later on, you will see in case of conductors, then it will be just sigma by epsilon naught. That's all. Yes, like in the case of capacitors, you will just have one conductor and field lines are coming only on one side. So that time use sigma by epsilon naught. Okay. Now understand what is the relationship between force and field. If you have a charge Q over here, then the force acting on it is given by, simply put, Q into E. That's it. Charge into field will give you the force. is it necessary force is in the direction of field? No. Why? Because if the charge is negative, then the direction of force will be exactly opposite to the direction of the field. So remember, the sign of the charge will decide whether field and force are parallel or anti-parallel. But it will never happen field is that way and force is this way. Well, this can never happen. No, that is not possible. Okay, so that's one thing, formula. And similarly, for gravitation also, you can write the same formula. For gravitation, understand, if this is the direction of the force acting on that mass, that force will be m into E. But this E is gravitational field, not electric field. Because electric field will only apply on charges, gravitational field will only apply on masses. Keep that in mind. Alright. Okay. I hope this is fine. Yes, Fida, very good. Okay, so let's begin. Let's begin with some problems. Are you guys now ready for some problems? Shall we do a lot of problems now? A lot of conceptual problems coming on your way. Theory is mostly done. I have given you most of the formulas. Now I'll be doing problems and I'll be talking about flux and gravitation at height h and depth d after some time. So hold on, stay tuned, do not leave or do not get confused or do not think, oh, the class is so difficult. Do not worry, it's all going to be there in your head. You will all understand eventually. Alright, so let's do that. And before that, let me tell you that because we have extended the Diwali sale, it's very important that I tell you about this. So many students were pinging about the Diwali sale, and that's why we have extended the Diwali sale for pro subscription courses, where you get this kind of teaching with assisted teachers, personal teachers, doubt clarifiers. You will get a separate set of teachers only for clarifying doubts within the app, and also the test series assignments, because a lot of you want a lot of problems to practice. So how do you get that? Using these tests and assignments. And you have also the option of language, either in English or in Hindi, and you get additional courses like the crash courses, the micro courses, and KVPY course, board course, Olympiads. We have a dedicated set of teachers just for Olympiads, a dedicated set of teachers for KVPY, dedicated for NEET, dedicated for IIT JEE. It's not like just like it happens in regular coaching institutes, same teachers are teaching everywhere and there's no proper planning. No, here there are dedicated plans for every kind of examination, so keep that in mind. So understand, if you are interested in this, so for 12th standard students, 50% off is going on all these rates. These are the actual price, right? So you'll get 50% off with the cap limit of 10,000, of course, and so that's a big saving that you'll be getting. So do not hesitate to join right now. 11th standard students, these are the prices for each duration. So for 12 months it's 42,000, for 1 month it is 5,000, and there is 50% off with a cap limit of 10,000 again on that. That's a huge saving that you will get. And all the dropper students, for 1 month it's 9,000, for 6 months it's 51,000, again 50% off with a cap limit of 10,000 out there. All right. And yes, for using how do you get the discount? You have to use this coupon code SHHPRO. So this is a coupon code SHHPRO. By using this coupon code only you will be getting those 50% discount rates. The offer ends on 15th November. So you have to decide really quick and you have to use this coupon code. All right. So what will be my next chapter in 11th standard? Well, that will be momentum and collisions. That will be on Monday or Tuesday. Okay. So here is the next question, guys. Let's see what the answer should be. I will be giving you 1 minute of time, and I hope you will solve this question within 1 minute. Manju, I'm not sure which other person will do this in detail, and that too within 3 months. Believe me, with the amount of time we are giving you for each chapter, 6 lectures to 5 lectures for electrostatics, guys. I mean, that's unheard of in a crash course. Sinchan, I'm not sad. Why are you saying that? Oh ho ho ho, I think there was a guys, this should have been 10 raised to 4. I think this was not 1110. Yes, thank you for pointing it out. I'm just ending it because I think the field value given over there was slightly wrong. Yes, Manju, for sure. So I think this was supposed to be just 110, all right, not 1110, all right. So that was, yeah, so the power was 10 to the power 4. I don't know whether it is seen on your small mobile screen, but it is 10 to the power 4. Okay, so I'll just do this question in front of you. So a charged oil drop is suspended in a field. What is the field value? 3 into 10 to the power 4 SI units. So that is not falling nor it is rising. Then the charge on the drop will be how much? Mass is given and G value is given. So guys, let's try and solve this problem. So again, I just shown that charge. Again, let's forget that one. So think, what kind of forces will act on the charge? One will be the own weight, and if it is at rest, because it is at rest, it is not moving up nor is it falling down, that means there must be another force acting on it, but this should be electrostatic force. So clearly the electric force must be equal to the weight, and what is the weight? Mg. And what is the electric force? It is K Q, or oh, one second, I can just write it as field into the charge. Remember, force or due to a field, it is nothing but the charge itself into the field. So that is the formula that I'll be using. So what is the charge? That's what I need to calculate. What is the field? I think it is 3 into 10 to the power 4. And what is the mass? The mass of the charge, let's take it as 9.9 into 10 to the power minus 15. And what is G? G is nothing but 10. So solve this and see what is the value of charge that you get, guys. Come on, what is the value of charge that you get? It's very simple. 99 by 3. Come on, 33. So what will be the answer? 3.3 into what will be the power? Come on, guys, what will be the power? Yes, it is Millikan oil drop experiment. This is how it was done. Correct. Okay, Nijerson has given something and something. Science Priya also has given the same answer. Is it 10 to the power minus 18 or no? Yes, it is 10 to the power minus 18. Very good, very good, very good. Excellent, guys, excellent. So this is the value of charge in coulombs. Alright, so this is the value of charge in coulombs. This is a very famous experiment called as Millikan oil drop experiment. Millikan oil drop experiment mein he dropped different oil particles and he saw when they were at rest, he saw what was the value of the charge, and he saw that the values of the charges were always in the multiples. No matter how big or small the drop was, it was always in the multiples of 1.6 into 10 to the power minus 19. From there he got the idea, oh, 1.6 into 10 to the power minus 19 must be the smallest possible charge. That's how it is. Okay, excellente. Let's go ahead. Next question coming up on your screen, and here it is. An electron is projected with certain velocity into an uniform electric field at some angle. Then it is which of the four options? Which of the four options? Come on, guys, think about it. Let's start the countdown timer immediately. Very good, Pija. Yes, I think you would have studied that in chemistry as well. Read the question very carefully, guys. Read the question very carefully. Come on, come on, come on. You can do this. Come on, guys. Everybody answer. Come on. Everybody answer. Everybody answer. Come on. Poetry, Fidak, Rito, Saurabh, Gopal. Okay. Science Priya. Acha. Come on. Come on, guys. Time ends in 5 seconds. Mixed answers. Okay, so let's see what the answer should be. When the field is uniform, the interesting thing is understand the force acting on it will be Q into E vector, and this force is also mass into acceleration. So if you rearrange the equations, what will you get? You will get acceleration is Q by M into E. Now, isn't Q by M a constant? Think about it. This Q by M is a constant. What else is given? Uniform field. Uniform electric field means what? E is also constant, not just in magnitude but also in direction. So this is how the field lines should look like. They're all constant and pointing in the same direction. Magnitude wise also they are same. So if both are constants, what will happen to the acceleration? Won't acceleration be also constant? And hence that is the answer. Now I'll tell you one very interesting fact over here, guys. Okay, so that's how it is. The correct answer will be acceleration will be uniform. The interesting fact is, the moment you understand this particular concept, remember, you can always treat this acceleration, yes, this acceleration, whatever you have found, as G. You can treat it like G, and if you get a problem with field and charges and masses, you can use all the projectile motion, free fall motion formulas directly over here without having to worry about it. Yes, without having to worry about it. And how you can do that? Imagine, guys, if there was a question something like that which said that there are two plates and they are charged like this, because of which there is some electric field which is created in this direction, and there is some charge over there, okay, some charge and some mass. So if I have thrown that charge with some velocity like this and it is going in a path this way, and maybe that angle is theta, and if the question is, if I've thrown it from this plate, okay, I think I put plus here also, I should have put minus. If I've thrown it from this plate, and the question is, after what time will it land on this plate? Again, if that was the question, use that normal formula 2v sine theta, but instead of G, what will you put instead of G? Think about it. Instead of G, you will put A. And what is that A? It was Q by M into E. That's it. You will get the answer. So understand, all these uniform field problems can be solved using the concept of gravitation and time of flight. Yes, kinematics in electrostatics. Prajwal, thank you. Join in the class. Concentrate. Thank you very much. But okay. So let's go to the next question. The correct answer was accelerated. Oh, why is it given accelerated non-uniformly? That is wrong. At an, so this is accelerated uniformly. So A is wrong, B is correct. Alright, so B is correct, guys. I think the answer mentioned over here is wrong. So it is accelerated uniformly. Understand that. Okay, so let's go to the next question coming up on your screen. So two point charges Q and minus Q are separated by a certain distance. The resultant field is parallel to the line joining the charges at which points? Chalo, start this question, giving you 1 minute for solving this. Very good poetry, very good science, Priya. Good maintaining it. No problem, Krito. I hope by the end of the series of Flash you will be good at everything. Come on, Prajwal, you also answer. Okay. Come on, everyone. Time is ending in 5 seconds. And the time is up. So, 2 point charges Q and minus Q are separated by certain distance. So let's say this is plus Q and this is minus Q. And the resultant electric field, alright, is parallel to the line joining the charges or the points. So this is the line joining the charges. Now first of all, let me remind you of how the field lines look like. I hope you remember the field lines I had just shown you some time back. They looked something like this. And the same thing continues down also. It goes from there and comes from there like this. And the same thing is also there below as well. Aren't these the field lines? Now see, where are the resultant field lines? So these are the field lines that we have already seen. They are parallel to the line joining the charges. Which points? Well, it's here, 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 everywhere on the perpendicular bisector. So what is this? This is a perpendicular bisector. So everywhere on the perpendicular bisector, including the midpoint, that's where you will see the field lines are parallel. Is this understood now, everyone? Okay, very good, very good. So Jay, I'm not strict. Yeah, what made you say that I'm very strict? I just want people to enjoy the class and behave, that's all. And you know what kind of masti we do. We had cricket sessions, and tomorrow too, I'm even talking to everyone on Instagram. I'm having a talk session with all of you right on my Instagram channel as well. I don't think I'm strict. What do you guys say, guys? Okay, okay. Chalo. Okay, let's go ahead. So the answer was both of the above on the line joining the charges. Yes, there is one point on the line joining the charges and on the perpendicular bisector. Okay, so there are 2 points where you get it. Thank you, Dami. Chalo, let's do this question. Let's do this question. Two concentric shells having radii r and 2r have charges q and minus 2q. Then find the field as a function of distance. Very, very interesting question. This can be an advanced type of question. First, let me write down all the informations. So radius is r over here, and this radius is 2r. The charges are q and minus 2q. So this charge is q, this is minus 2q. Now the question is, find the field as a function of the distance. Let's do this, guys. Observe. First, I'm going to be in this region. Okay, I'm going to be in this region. So this is going to be my r, and then slowly I will move out. I will come over here, and then I'll come further out. Okay, I'll come further out. Let's say over here. So this is where I'll come. So these are the three distinct regions I have identified, and let's write down the field at all these points. First, in that region over here, I feel I'm inside both the shells. Remember, when you're inside a shell, what is the field? 0. So due to this shell and due to this shell, both of them will have 0, 0 forces or 0, 0 fields. So the answer is 0 when r is less than r. So that's the first answer that we got. I hope this is fine. I hope this is fine. Okay. Now, the next thing, guys, what is it? The electric field, guys, between these points. Think about it carefully. Because of the minus 2q charge, the outer shell, don't you see? Because of the outer shell, the field will be 0 when you are inside this big shell. Forget this part. Because of the outer shell, the field will be 0 because you are inside it. So that minus 2q has no contribution. But for this shell, you are outside. So this shell will behave like a point. And how far are you? You are at a distance of small r. So just use that formula. So it will be k q by small r square. That's it. This is when you are somewhere here. And which side will it be? I think the field will be outside because this charge is positive. So the field lines will be outside. So I will just say it is outward. I'll just mention it here instead of putting a sign. This is a magnitude. This is the direction. It is outward. Is it clear, everyone? Is it clear? Now, the last part. When you are completely out, so think about it. When you are completely out, both the charges will behave like one single point charge. Think about it. Both charges will behave like one single point charge. What will be the value of the charge? Q minus 2q, which will be minus q. So I think the field lines will be inside, inwards, and it will be k q by r square. But this is when you are beyond this and the field lines will be inwards. That's the answer, guys. These kind of questions can come in multiple choice, match the following, and so many other places. Very good, very good. So that's how you can solve. So there are questions where you will have one more shell and then find the field. So that also you can solve. And once we learn Gauss law and once I take one advanced session, you will see what will happen if I connect one of them to Earth. Yes, those kind of questions also come. What will happen if I connect it to Earth? Then what are the charges? So those kind of questions I'll solve it after Gauss law, not now. Alright, so let's do that later on. Now let's go to the next question. How about this? A long wire is at a distance d from a huge charge sheet, alright, having charge q and area a. Find the distance at which there is a null point. What is the meaning of a null point? Null point means the net field is 0. That's all it means. So null point means the net field acting on it is 0. Okay, so let's think about it. There is a charge sheet that will be giving field in both the directions. Okay, so this charge sheet will be obviously giving field in both the directions like this from it. And what will be the value of this field? We all know it is sigma by 2 epsilon naught. But what is sigma, guys? Charge by area. So it is q by a into 2 epsilon naught. So that's the value of the field because of the sheet. Alright, next let's talk about the wire. Because of the wire. Now what will happen because of the wire? Wire will also give field in all the directions. Alright, so there will be field even because of the wire like this. So this is the field because of the wire. So how much is that value going to be? Think about it. I just gave you one formula. 1 upon 4 pi epsilon naught lambda by r. R is the distance. So I want to know at what point do I get it. So let's say I call this as x. Okay, that is x. And remember there was sine alpha and sine beta. Sine alpha plus sine beta. So here that will be sine 90 degrees plus sine 90 degrees. Why is it 90 degrees? Because if you are here, this wire is never ending. Alpha is 90, beta is also 90, sine 90 and sine 90. That's why you will get these two terms. And what will it become? 1 by 2 pi epsilon naught lambda by x. So that is the answer for this. Now to get null point, what should happen, guys? Think about it. This field should be exactly equal to this field. And the directions are exactly opposite. I hope you see that. Yeah. So the directions are exactly opposite. So the field from this and the field from this should cancel out each other. So that's it. You substitute the values and you will get the answer. Q by 2 a epsilon naught should be equal to 1 by 2 pi epsilon naught into lambda by x. That's what you will get. So 2 and epsilon naught will get cancelled and I'll get q by a is equal to lambda and that pi remains x. So that's what I will get. So x will be obviously equal to lambda a by q pi. That is the final answer. So at this distance from the wire, the fields will cancel out each other and you will get something called as the null point. Very good, very good. There is charge on this wire as well. It's clearly given, the long charge wire. So this charge per unit length is given to be lambda. That is what is given. Shreyas Paliwal, I feel both are equal. If you do not understand 11th, then 12th is tough. But if you understand 11th, then 12th is easy. That's how it is. Because many topics are related to each other. And if you develop the visualization, the problem solving skills, the analytical skills in 11th, then 12th becomes easier. Yes, it's the same kind of null point that you have in magnetism. Okay, so guys, what is the formula for gravity at height h? Do you know the formula for gravity at height h? Let me give it to you. So if you are at a height h, the formula is capital G m divided by r plus h whole square. So this is the formula for acceleration due to gravity at height h. You should know this. You should know this. As h increases, g will decrease. Because the farther you go, the force of gravity will decrease. This is one important formula. Keep this in mind. Very, very important formula. Alright, keep this in mind. Next formula. Gravitation at depth d. Very important again. So what is the formula for that? So let me give it to you. So G is equal to, if I take this much as small r, the answer for that is Gm, alright, divided by r cube into r, sorry, this is just small r, my bad, this is just small r, that's it. So now if you remember this form, then you can easily get the other form. So it will be into r minus d. So that is the formula. So you can either remember it this way or this way. If you remember it this way, I feel it is easier. Why? Because this is the same formula that you have for forces and field, Gm by r cube into r. But this small r is always from the center. If you want to remember it the other way, then also that is also fine. R is the radius of the earth, d is the depth. Understand? So this is the depth. This is from center, if you measure it. Alright, both formulas are equal. Alright, so let's do a problem based on this. Let's see how many of you get it. Come on guys, let's see how many of you get this. I'm going to give you 1 minute to solve this problem. Come on, let's see how many of you get this. I've started the question. Very good, Rushita. Chalo, very good. Science Priya. Jyot Kaur, very good, very good. Fila, come on, keep the chats coming. Very good, Aarti, very good. Come on, keep the chats coming, keep the answers coming, keep working. Come on, come on, come on. Guys, it looks like today I might have to extend the class a little bit. I hope you guys are okay because I also want to talk about flux. What say guys? As we enthusiasts, are we ready to extend the class a little bit today? Alright. Stopping. And the correct answer is this one. Very good. I can see your responses. All of you are ready. That's the Josh, guys. I exactly want this. I just want committed students. I just want committed students. Believe me, you will be surprised to see how committed I am towards you. You don't know. I mean, see guys, I'm not only responding to your Instagram doubts, I'm also, or responding to your Instagram chats, but I'm also responding to your comments, even in the YouTube sessions. Also have my regular sessions and I solve doubts there, and also I make my own slides over here. So a lot of things. So I'm really committed towards you. So I need to see that commitment from your side. The moment I see that, believe me, I do a lot of things for you guys. I understand that. Alright. So weight of the person has to reduce to how much kg? 30 kg. So if the weight reduces from 60 to 30, that means whatever the gravity was there on the surface, that divided by 2 is the gravity at height h. That is the logic I thought about. Alright. So gravity at the surface divided by 2 is the gravity at height h. Now what is the gravity at surface? Use this formula. Gm by r plus 0. Because height is 0, that means you are on the surface. And that thing divided by 2 should be equal to gravity at height h. So Gm by r plus h whole square. Now this Gm and this Gm will get cancelled. Invert it and take square root. Okay, invert it and take square root. So it will become r square root will become just r, root 2 will be r plus h. Now rearrange, I think you should get the answer. H will be equal to r into root 2 minus 1, which is this answer. That's how you get it. Very easy. Very easy. Very good. Very good. Excellent, guys. Excellent. Let's go to the next question. Let's see how many of you get this. Many of you got the previous question. Bahut hi badhiya. Let's do the next question. Oops. One second. Okay, starting the countdown. Read the question. If the radius of the earth is 6400, the depth at which acceleration will be 5% less than the value on the surface. How much is it? Don't look at the option, just start solving, you'll get the answer. Looking at the options, you'll get confused. Yes, VSG, but the question asked was at what height. So if the question says at what height, then you will not go inside. But yes, you can also reduce the weight by going inside. That's also correct. Very good, Rushita, Bhavya, VSG, very good. Come on, come on, come on, Ryan, Krito, Dami, Poetry, Aarti. Come on, guys. Time is running out, time is running out, time is running out. Okay, a lot of you people have said A, some of you have said D. Shivam says A, okay. Yes, physics lover, why not? And that's why we are here, to make impossible things possible. Yes, guys, all those of you who said A are correct. And let's see how. At what depth is the value 5% less? Now, should I tell you the long way or should I tell you the short way? I'll tell you the short way. I'll tell you the short way. Chalo, here it is. Shortcut trick. See guys, gravity with distance changes like this. This is your radius of the earth. Inside the earth, the gravity is linearly proportional. We just saw the formula, right? Gravity at depth D was gm small r divided by r cube. Don't you see that gravity is directly proportional to the distance from the center of the earth? So that's it. That's what you should keep in mind. So if the question says that the gravity is 5% less, that means whatever is on the surface, it is 0.95 of gravity which is there on the surface. That's what it means. If it is 5% less, isn't it? 5% less means it is 95% of whatever is there on the surface. Oh, okay. That means my distance from the center should be 0.95 r, because G is proportional to r. Think about it, G is proportional to r. So it should be 0.95 r. So what should be the depth is the question. I hope that's the question. At what depth? So what is my depth, guys? So my depth obviously will be 0.05 r. So if my depth is 0.05 r, so think about it, what will be the depth, guys? 0.05 multiplied by 6400, and that should give you 320 kilometers. Isn't it simple? Understood what is the trick you have to use? Even with formula you will get the same answer, but it will be lengthy. You have to start substituting and all that. I hope this is fine. What an interesting way of solving it. Loved it? Shivam, I am teaching gravitation and electrostatics together because they are related. But yes, satellites and Kepler's laws, I have kept a separate lecture next week. Just Kepler's law and satellites next week. And just for dielectrics and other things, a separate lecture. Don't worry, don't worry. Yes, while solving, use the radius as 6400 unless specified otherwise, Sakshi. Okay? Now, let's come to the last part. Let's come to the last part, and that is flux. So what is flux? See guys, a lot of people think flux is only there in electricity or magnetism. That is wrong. Flux can be there even in fluid dynamics. Flux is just flow of something. Just imagine, these are streamlines of water. These are water ke particles. These are the streamlines of water. So if I say, what is the water's flow flux? Means how much volume of water is flowing per unit time. That's the meaning of volume flow flux. Understand that. So flow of something is called as flux. So if I have electric field lines, I can think of it like streamlines of water. So I can just think, oh, how many of our lines are cutting through a given area? That is the measure of the flux. So understand one very important thing. This line will change your complete understanding of flux. Just the word flux, or just I can say electric flux in this case, is always directly proportional to the number of field lines. This is also applicable for magnetic flux. Number of field lines. Now just think, the same area, if I tilt it like this and make it perpendicular, don't you see the number of field lines cutting through it is more? Did you see that? Number of field lines cutting through it is more. So here the flux is really high. But the moment you start tilting, did you see some lines missed it? Did you see some lines missed it? So don't you see the flux is 0? And just imagine if I could somehow make that area go like this. If the area is like this, so can you guess what will be the flux? The flux will be 0. The field lines are just passing over it, they are not piercing it. It should pierce, only then there is flux. If it is sliding through it, if it's not piercing, then the flux is not there. Understand that. Alright, so very important concept. And how is flux going to be dependent, or what is the formula for flux? I'll be coming to it in 1 second. Understand, if this area, okay, just 1 sec, let me go behind. If this area was little bit larger, won't I capture the other field lines? Can you see that? If this area was little bit larger, I'll be able to capture other field lines. So flux is proportional to the area. That's number 1. Also number 2, you can see it is dependent on the angle. That's number 2 point. Number 3 point, if my field itself was stronger, then won't I have many more field lines passing through the same area? So won't the field be higher field cause higher flux? So flux depends on field, angle of that area, and the area itself. So 3 quantities that it depends on. So hence understand the value of the electric flux will be EA cos theta. If theta is the angle between area vector. So guys, area is a vector quantity. If you think, how is area a vector quantity? Let me tell you. I just taken my writing pad. This is where I write in all my regular classes, by the way. So if this is an area can be defined as a vector by taking a perpendicular to it. So this is the area vector. Okay, so this is the area vector. Okay, so area vector is a vector which is perpendicular to the area itself. So if my area is like this, area vector is here, field lines are here, the angle between the area vector and the field lines is theta. Understand that. Okay, so that's the angle between them, and it will be EA cos theta. You can clearly see if theta is 0, the plane will be perpendicular if theta is 0, and you will have maximum flux, because cos 0 is how much? How much is cos 0? 1. Maximum flux. Remember the previous diagram? And if I tilt that area like this, then theta will be 90 degrees. There will be no field lines piercing. Cos 90 will be 0. Is that formula understood? Very good, very good. Captured. Excelente. Amazingo. Let's do 2 problems. What say? 2 problems and that's it. Let's do 2 problems. Chalo, let's see how many of you get this. Very interesting question. I'm starting the timer for this in a bit. In a region where field is constant, 8 I cap, 4 j cap, 3 k cap, what is the electric flux through an area of 100 meters square in XY plane? Starting the quiz now. Come on guys, come on, come on, come on, come on, come on, come on, you can do this. KK, it's difficult to understand why it's a vector quantity, but we have defined it to be a vector quantity. We have given it some direction, that's all. Just for convenience sake. Because it makes our calculations and mathematics easier. Is that okay, KK? Thank you, Sai Reddy. Come on, start solving the problem. Krushita has given some answer. Krito, BSG have also given some answer. Answer is B. Okay, let's figure out. Come on guys, hardly 12 seconds to go. Okay. And all the dropper students, I have a special announcement for all of you. The dropper students, I have a special announcement. Just hold on for it. So guys, here is how you should do it. First, visualize the diagram. So this is my area which is in the XY plane. This is my x-axis, this is my y-axis, and this is my z-axis. This is 100 units, and that is my electric field. You know what I'll do? instead of visualizing this problem, I will use dot product technique and think how the area vector will be. This will be my area vector. Area vector magnitude wise will be 100 units, but it will be in this direction, so it will be 100 k cap. See, observe it. Area vector is in this direction. Remember, a perpendicular to the xy plane will be in the z axis. So magnitude wise 100, direction wise k cap. That's it. My job is done. Now flux was EA cos theta. So somebody was asking why area is a vector. So it makes our calculations easy now. So if I do E dot A, see how easy it is. Without visualizing, I can do it. So it will be 8 I cap plus 4 j cap plus 3 k cap dot that area vector, which is 100 k cap. Now we know how to do dot products. I does not go with k, j does not go with k only goes with k. So how much will it be, guys? It will be just 300. And what are the units? It will be unit of field, which is Newton per coulomb, and unit of area is meter square. So that is the answer. Is it understood how to solve this? Yes, cos means dot product. So if you treat them like vectors, calculations become easy. That's why we have defined it. What an interesting way. Now the last question for you. So the answer was 300 units. Now let's go to the next question. Let's see how many of you get it. I am starting the quiz right away because it's simple. Be careful before you type. Superior, very good, Science Priya, very good. Be careful, multiple correct options. More than one may be correct. Think again. Kushi, Trishita, Madhav, Fida, NVD, Sakshi, think. Okay, chalo. A lot of you have given answers. Come on, 20 seconds to go. And the time is up. Okay. So the correct answer is B and C. Guys, you just had to visualize the problem. And if you visualize the problem, that's it. It's very simple. Are parallel to a plane area. So my area is like this. This is my area. And my field lines are parallel to it. That means they are like this. These are my electric field lines. Don't you see? My area vector is like this and it is perpendicular. So cos 90 degrees is 0. So obviously the flux passing through that plane is 0, and in fact it is the minimum value in magnitude, because you cannot have lesser flux than 0 magnitude wise. So definitely it's not maximum. Maximum will be when it is like this and the field lines are piercing through it like this properly. So the answer is B and C. What an interesting way to solve it. So like I was saying, for all the droppers and the 12th standard students, I have an interesting announcement. Some of you are saying, sir, what if I don't want the subscription? What if I just want only the crash course? There are a lot of students like that who just want the crash course. They want test series, they want test discussions, they want problems, they want question bank. For the last minute preparation, you want that additional boost, only the crash course. And you don't want to pay for the subscription. So there is an option for that. Well, by the way, let me tell you, in the crash course, you also get the doubt feature. So you can ask our doubt experts, subject matter experts, all your doubts. So all your doubts will not go unanswered. There is somebody who will solve it. All right. And all these classes, you will get the recordings. So you can play it again and again. So what's the way to do it? Guys, there is a crash course and the coupon code for that is SHCC. The crash course was worth 10,000, but you will get it only for 8,000. And this crash course is going to run till the month of April, not January. A lot of people are thinking only till January. No. It is going to run continuously till the month of March or April, till your second attempt. Understand that. All right. So all those people who wanted to join only the crash course, understand the link is again in the description. So you if you don't want the subscription, so you can also take the crash course, and the coupon code is SHCC. The coupon code for pro courses was SHHPRO. That was a different coupon code. This is SHCC. So you can use the coupon code and you can get 2000 rupees off. That's like 20% off right away. Alright, so use that, and on the Telegram group I'll be posting the solutions of yesterday's session and the day before yesterday's session homework problem. I know most of you have posted the solutions in the answers in the comment box. So keep posting, keep commenting, keep liking. Guys, if you have not yet liked the video, come on, go ahead, like. We have to make this channel popular. We have to grow this family. And if you love me, if you like me, if you like my way of teaching, you should subscribe and you should like, because without that I won't understand it. All right, so come on, put some comments, give some likes out there. Thank you very much. It was a lovely session, and tomorrow I'll be meeting you live on Instagram. My Instagram handle is Shreyas_Vedantu. Alright, and on Monday I'll be conducting a very special session. You will see what it is, so stay tuned. Bye bye, take care. Have a safe Diwali, have a very prosperous Diwali. Wishing all the V enthusiasts and their family members a very, very happy and prosperous Diwali. Bye bye, take care. This was Shreyas here signing off now.